My name is Kainton, the Tech Pro, and today we are now going to continue with binary search tree implementation. And today we are going to use the iterative implementation. So let's rewrite this code so that we now use iterative implementation. Remember, the method, the algorithm is exactly the same thing. It's just the implementation can now be iterative. So what makes this recursive is actually this return BST, and then we are calling BST from the code. We are calling the same function right from inside the code, so that we actually will get rid of that. So instead of actually starting to modify this, let me write a completely new function, and then I'm going to be explaining it line by line. So let me start by copying and pasting this one. So now I'm going to call it BST, and I'm going to call it recursive. So this left and right, we are going to remove it because we don't need any recursive call. And then, in fact, I'm going to just take out everything from here. So at this point, I think it's okay. So, so the first thing we want to do is to set left and right, because now we are not doing any recursion. So we need to set left and right in here. So int left is equal to 0. So what it means is left is now the first position, and int right should be ar.length -1 because it's 0 based. Okay. So so we are going to say while left is less than or equal to right, while left is less than or equal to right. So I'm going to show you shortly exactly what we are doing. So, all right. So at this point, I'm going to now draw so that I can explain. So at this point, we have something like this. I don't know why I can't draw straight. So let me try again. So assuming we have something like this. Okay, I think I got it now. So basically, we are doing the same thing, but we are not going to be using recursion. So we are going to say this is left as before, and this is right as before. Okay. So again, we are going to also be taking the midpoint from here. So now we are going to be calculating the midpoint as left right over 2. Okay, fine. And then we are going to be saying that after each recursive call, we are going to set the midpoint. We are going to set the right to be the midpoint -1 and left to be midpoint +1. So more like this right is going to shift, or just like before, is going to shift here, and left is going to shift here as before. Alright, so I just want to emphasize it so that you understand exactly what is happening. Alright, so we are going to calculate the midpoint. So I'm going to say int mid as before. So I'm going to just copy it instead of just writing it out again. Copy and paste. Okay, so this is fine. So we're going to left, right, while. Okay, fine. We are going to check if the midpoint element is actually the key we are looking for, right? So that is what we did here. If the midpoint element is the key we are looking for. So if it's a midpoint, if the midpoint element is the key we are looking for, just return it. Else, so I'm going to actually take these two, and I'm going to change things from there. So else, I'm going to else if x is less than, okay, so here I'm going to take out this recursive call here. So I want you to understand that the procedure is exactly the same. So now we are going to manually set the right. So if this is the case, we have x is less than ar.meet. If it's less, then we are going to set the right. It means that the left will remain where it is. The left index, that is here, will remain where it is, but right is going to shift to midpoint -1. So you can actually pause the video and try to understand exactly what this happening means. -1. So and in this case we have left is mid +1, more like the opposite of what we did in case of right. So left is equal to mid +1. Alright. So now we are not recursing, but we are now looping through. So basically it's the same thing. So I'm going to call BST recursive. So at the end of the day, if it did not return here, it's going to return false. So if it returns true, fine. But if it doesn't, it's going to then return false at the end. So meaning that the item is not there. So I'm going to call BST recursive, like calling this BST recursive. So I'm going to say Control V here, and I'm going to pass it array. This time we only need array, and we need the key to search will be 7, right? So we are having error. Where is the error coming from? Syntax incomplete. Okay, perfect. I think I should put one more braces, bracket. So I'm going to save and then run it. Let me see how it looks like. So you can see that it says false. So it's working. Let me search for 9. I'm going to search. Let me enter 56 so that we can exactly make sure whether it's working or not. So it says 56. So now it says false, which is very strange. 56 is there. It says false. Let me save and then run. This is very strange to run application in Java. So so it seems to me that, okay, let's see. 56 is in there, but it says false. Okay. Key 1 minus 1. Okay, let's see. Mean AR mean is equal to X. Everything should be fine. So return true. So what is happening? Right is mid -1, left is mid return false. So it should work. Okay, let's see. This is 3856 ARR56 PSC recursive. So let's run again. So let me try something else. Let's try 9. So 9 is returning true. So but 56 returns false. It's quite strange. This is 56. Okay, let's see. 56 is in there. Okay, so okay, I think I understand where the problem is coming from. So I'm going to change this to 10. And in the next lesson, because I've run out of time, I'm going to explain exactly what is happening to you, to this program. So it actually comes from the way the binary tree is built. So you can see it also says false, which is, so we have 3, have 8, we have 3, we have 10. So I'm going to stop here. In the next video, I'm going to explain what is happening actually in this place.